Hello. Alright, how's the mic compared to the background? Let's see if we can level it out. I'm still experimenting. I might drop the background on my own, honestly. Volume of the mic. And crank the mic volume up. Is that better? I'll just... There we go. I adjusted the audio down because otherwise I can't hear myself speak. How is everyone? Happy Monday. Who have we got in chat? This is like one of the things like that's weird about streaming, I guess, is pronouncing all the names. So I'm gonna guess SPUP API. That's how I read that one. If that is not how you pronounce it, if it's SPUPAPI, I'm sorry. And Al Hazred is here. Hello. I know he missed my last stream and was terribly upset. So it's good to see you. I always try and at least watch the first hour of your streams, though they tend to go on for like, I think one of the most recent ones was like 5 hours, and I was like, damn. Okay, who else we got? Tanimura 1000, hello. Ang31D. I've definitely seen you in the stream before, thank you very much. Ragnarok 08. I definitely remember you because it took me a while to figure out that your name was Leetspeak. Okay, GR Tomps, howdy from Texas. Howdy from Massachusetts. And Matchstick Boy, I think I got everyone. Hello. Okay, who followed recently? RXIYN or Rickson, thanks for the follow. There we go, there's another one. Ragnarok, how have you not followed me before? Thanks Ragnarok for the follow. Only took 3 streams. Who else we got? X Markin, MTLX, Vamtrock, and Ditty _. That's good. I presume you follow my Twitter, and that's how you get to all the streams, or possibly the Discord. That's the only 2 places I post them. It is awesome seeing everyone here today. Oh, hey, it's LGD. Hi, Tipsec. Nice to see you here live for once. Just started the buffer room of yours. Nice. Yeah, it's, I think I did this on a live stream. There's a video on YouTube. So definitely watch that if you haven't already. It's like only an hour long. We only go through the first one. And honestly, like, some of it was me figuring out that the script that I wrote didn't work in Python 3, which I was terribly embarrassed about. Okay. So what are we doing? You have to apologize. I've got a little bit of a tickly cough. But I have some water. So hopefully that will take care of it. Alright, we are going to do Portswigger. If you have not done Portswigger before, or you have no idea what Portswigger are, they are the company behind Burp Suite, which is basically the best web app hacking tool available. The guy who runs Portswigger, David Studdard, also wrote the Web App Hacker's Handbook, which is, or at least was, pretty much the Bible for web app hacking. Back in like, up until maybe 2015, maybe slightly other than that. It's an old book, let's put it that way. It's got some great content though still, and a lot of it's still relevant because the web mostly operates on HTTP 1.1 still. So, and it has for the last 30-ish years, I think. Maybe 20. So yeah, but effectively David was asked, like, when are you going to update the book? And he was like, I'll do it at some point. And then he decided, you know what? Books are awful. And the web is evolving constantly. If I write a book, it's like in 5 years, it's going to be redundant. So instead, he developed this Portswigger Web Academy, which is 100% free. Literally. You can create an account. You don't have to pay any money. And there are tons of learning materials. There's loads of labs. You can like boot up a lab in your browser. Again, completely free. And practice web app hacking. So that's what we're going to do. I have signed into my account. As you can see, this is a kind of this is a test account. I'm technically still a noob, but I'm almost at apprentice look. So if you unfortunately there's like 47 apprentice labs and not all of them are fun. So I kind of like been putting those off. I do have a second account. This is actually my second account on it, where I am, I think, at least a practitioner. So, but this is my Tiberius account. So, yeah. Let's go to the vulnerability labs. This is going to be a special stream. This is basically viewer-led. All right, you can see I've solved a bunch of stuff. Some of these I've solved on streams before. Like we did an SQL injection stream. We did an XXE stream. I think we even covered some XSS. But we're going to throw all that out the window. Basically, I want you guys to tell me what you want to see, and hopefully we're going to be able to do it. So let's actually get a list. I think there should be a nice list of the topics somewhere. So let's have a look. Okay. I mean, these are kind of the headers, right? OAuth, HTTP host header attacks, business logic, web cache poisoning, SQL injection. There's definitely a nice list. I think maybe if you click the Hall of Fame, you can sort via a list. My rank is terrible. Okay. So here we go. Here's a list of all the things we can do. So we've got access control vulnerabilities, authentication, business logic, clickjacking. Let's not do that. Trust me, I've tried some of the clickjacking labs. They are not that fun. Cross-origin resource sharing, cross-site request forgery, cross-site scripting, directory traversal, DOM-based vulnerabilities. Oh, goodness. If we choose that one. All right. Host header attacks, HTTP request smuggling. That is a fun one. Information disclosure, insecure deserialization, OAuth authentication, OS command injection, server-side request forgery, server-side template injection, SQL injection, web cache poisoning, WebSockets, and finally XML and external entities. So that is a big, long list. Hopefully you guys remembered it all. So I'm going to ask everyone type in the chat what they want to see, and I'm going to basically go off what I think is the wins the vote, because I have no idea how to do polls on Twitch, and I'm not even sure I can because I'm not affiliate yet. All right, so we have at least one. We have one vote against SQL injection. So SQL's at -1 right now. We've got WebSockets, OAuth, header, OAuth again, access control. Awesome. I have to admit, I have not played around with OAuth that much, so that might be an interesting one just because it'll be kind of just chucking all of us in at the deep end, really. I do not find many OAuth authentication methods in my regular job, so it looks like OAuth's going to win. Right now I think there's at least 4 people who voted for it. So we may have to go through the learning materials, but that's okay. I do know some OAuth tricks, but I'm sure we will learn. We've got some business logic. The business logic ones are actually kind of fun because they're honestly not so much. I mean, they are vulnerabilities, but they aren't vulnerabilities in the standard way. They're not tech-related vulnerabilities. They're not sort of exploiting some technology. They're really exploiting the programmer almost. So business logic vulnerabilities are always fun to find. The labs on these are actually kind of fun as well. But I think the people have spoken. Yep, hey, it's LGG has said. The people have spoken. I think we're doing OAuth. All right, so let's go for it. So I have my Burp Suite Pro window here. So we're gonna. I guess we'll go to the. Oh, there we go. Latest topic. It is actually a very recent lab. Who just followed? PE2ER. Thanks for the follow. Okay. So, OAuth 2.0. What is OAuth? Well, like it says, if you have used the web at all, which I'm sure all of you have, you've come across sites that let you log in using another sort of login, right? So Google, Facebook, I think even Twitter. And so they let you log in using a social media account, right? And most of the time, that's using OAuth 2.0. And I'm not going to go into the massive details about it, but effectively, if you haven't set it up correctly, there's a ton of things you can abuse with OAuth 2.0. And so we're going to work through and we're going to explore some of these vulnerabilities together. All right. So let's, I guess, jump into the labs and see. Oh, okay. So it's gone. It's done now. All right. What is OAuth? I think we can just skip that. All right, how does OAuth 2.0 look? Let's start here. All right, it was originally developed as a way of showing access to specific data between applications. It works by defining a series of interactions between three distinct parties, namely a client application, a resource owner, and the OAuth service provider. So client application, like for instance, would be the actual application you want to log into, right? The resource owner is you, okay, right? You're the person trying to log in. And the OAuth service provider is the social media account that you're trying to log in as. And yeah, Ang31D, it's a bit like SSO, right? So it's not exactly SSO, it's kind of similar. So SSO, for those who don't know, stands for single sign-on. The idea being you sign on to a service once, and then you can use that sort of authentication token elsewhere. It's kind of like single sign-on. It's a bit trickier though. As you'll see, it gets kind of complicated. So let's scroll down. Before learning how OAuth is used, authentication, it's important to understand the fundamentals of this basic OAuth process. If you're completely new to OAuth, we recommend familiarizing yourself with the details. All right, so let's click read more. Ooh, I'm getting some alerts. James Harris, thanks for the follow, and Zicarelli too, thanks for the follow. Okay, what is an OAuth grant type? OAuth grant type determines the exact sequence of steps that are involved in the OAuth process. So the grant type also affects how the client application communicates with the OAuth service at each stage, including how the access token itself is sent. For this reason, grant types are often referred to as OAuth flows. An OAuth service must be configured to support a particular grant type before a client application can initiate the corresponding flow. The client application specifies which grant type it wants to use, and it sends that to the OAuth service. Okay, and the scope, pretty much, if you'll see when you're doing OAuth authentication, if you like hijack the requests, they'll send this scope variable usually, like a scope parameter, and that basically tells the the OAuth server or the service like which client application you're using. I think we can probably skip all this. This is just how it works. See, extremely complicated. But yeah, it's kind of like SSO, right? So this you'll see this diagram as SSO as well. Okay. The authorization request, right? So the client application will send a request to the OAuth service's authorization endpoint, and they'll use like client ID, a redirect URL. There's this scope here, right? Maybe we'll go over those later. I'll tell you what, we'll dive into the first lab and see if we need to do some revision. I did solve this one, so this one must have been easy. All right. The lab uses OAuth service to allow users to log in with their social media account. Flawed validation by the client application makes it possible for an attacker to log into other users' account without knowing their password. All right, to solve the lab, log into Carlos' account. His email address is this. You can log in with your own social media account using the credentials Weena and Peter. All right, so we'll access the lab. And this is going to be proxied via burp. I just need to add it to the target scope. Okay, so I need to add that. And yeah, we'll avoid collecting all this crap. Okay, so here we have basically all these requests were just loading this. So if we go to login with social media, let's see, did that do anything else? Okay, so it did, right? So this GET request was sent to the auth page, I think is... No, it wasn't there, all right. So there's a GET request to auth, which contains the redirect URL, okay? In this case, it's going to... So this is a completely separate site, right? This is the third-party site. No, I got that wrong. Okay, this right is the client site we're trying to sign into. Okay, you can see it's AC70, right, which is what we loaded originally. And so by clicking sign on, we went to this AC53 site. Okay, so this is the OAuth provider. All right, and we told the OAuth provider, okay, we want the redirect URL. Where we're going to redirect back to is this. Client ID is this. So the client ID in this case is the ID of the site, right, that we want to sign into. Response type, we want a token. There's a nonce there. That's just basically kind of like a one-time number. And then the scope is OpenID profile email. Okay, so and I don't think that does anything. Yeah, that was just the site that loaded. So let's sign in using our credentials that we have. Okay, I will save them. Let's see what happened again. Okay, so we posted the credentials to this OAuth server, and then we made another GET request, which responded with a redirect. Okay, so this redirect went to, it was still on the third-party server right now. Okay, and effectively it's gonna, I think this is what we got here. This basically almost like a pop-up saying, right, we like to blog, which is the site we were trying to sign into originally, is requesting access to your profile and your email. Okay, and that's, I guess that makes sense, right? Because when we originally did this, it was asking for profile and email. Okay, so that was the scope, right? So the application's saying, okay, the scope is I want to share profile and email address. So that's fine. We'll click continue. And now you see we've been redirected. You might not have seen it up there, but if I go back here, when we did the confirm and we hit that confirm button, we got redirected. You see the response back to the original site, I think. Oh no, okay. The redirection happened here. So we got redirected again to the same site, and then once again we get redirected back to this OAuth callback. Okay. An OAuth callback, if we go all the way back up here, where is it? To there, right? So the first request we sent to this OAuth server, this was the URL, the redirect URL. Okay. So that's where that comes in. Basically, the redirect URL is telling the site, okay, once the authentication is done, redirect the user back here. And so we did. And then effectively it's going to post. So this token, it's going to pass and it's going to use it as authentication. So that token comes, I think it will happen. Yeah, here. So the actual redirect passes a token as part of this fragment. All right, so it's not actually going to be seen. It's basically client side. Okay, so if you're looking at a URL and you come across in like after the path, after all the parameters in the URL, if you come across an unencoded like hash symbol, that's a fragment. That basically means it's not going to send any of this to the actual server. This is just going to be within the browser. So the browser is going to have this access token and all this information. And so the browser, when it actually loads the OAuth callback, you'll see it's going to get the access token from the URL. And then it's going to create it, I think create the token somewhere using a bearer. Or it's not actually. Okay, so it's just gonna put it in there, and then we're gonna be authenticated, right? So now we're authenticated. So you can view the My Account page. But what you may have noticed, right, is technically all the authentication happened here, right? And then when we got back to the site we were trying to actually authenticate to in the first place, it did a post to /authenticate. And it sent an email address, a username, and a token. Okay. And there's really nothing it's doing to verify that this token belongs to this user. Okay. Or at least in this case, there isn't, right? Ideally, there'd be a way to verify that this username or this email matches this token. But there isn't in this case. And so to effectively bypass this, the way that you need to solve the lab is you have a valid token. You just need to change the username and email. So we know that Carlos has this email, carlos at carlosmontoya.net. So if we replay this authenticate and we substitute in Carlos's email and we type Carlos as the username and we send that, so we get a 302 found exactly like the same before, with a new session token here. So we'll copy that out, and let's then go back here, and I'm going to make sure I zoom in on this page so everyone can see it. You might not be able to see what I'm doing right now, but I'm basically going into the inspect tab, right? And there's application and the cookie here. Right, the cookie is currently set to GWH4 blah blah blah. If I paste in that new value that we got, okay, that's now changed the cookie. And so if I just click home again, and then I've done it. But if I click my account, you'll see we're logged in as Carlos. Okay, so that's basically happening because there's no verification being done, right, by the actual web app itself. Okay, we're using OAuth, but there's nothing stopping us from just changing the username and reusing that valid session token. Okay. So any questions on that? Right, so because the authentication was done on the other site, that site returned an authentication token in the redirect, right? So it was an access token. Oops. Here we go. I keep misclicking, I'm sorry. So it returned an access token. All right. So it basically verified that the user existed and said, okay, yeah, this user has an account, and it redirects back and it passes back an access token. And then that access token was used with this data, which was not validated. How would you verify the token belonging to that user? I think if we keep going in the labs, we'll see. If we go down here, yeah, I'm just trying to see that. This is honestly one of my limitations with OAuth. Is I haven't done much testing with it, so there's no real need to actually rely on this stuff. But you know, we're in this together, so we will go down and we'll see what we can do. So was there anything in this? I guess if we click OAuth authentication vulnerabilities, this is one of my main complaints about Portswigger, is finding the labs is sometimes a bit tricky, especially if you want to go in order. So we found that one. Is there... Yeah, see, this one just brings us up to the same one. Okay, flawed cross-site request forgery protection. Although many components of the OAuth flows are optional, some of them are strongly recommended unless there's an important reason not to use them. One such example is the state parameter. The state parameter should ideally contain an unguessable value, such as the hash of something tied to the user's session when it first initiates the OAuth flow. Okay, so actually this answers that question, right? So the state parameter contains an unguessable value, such as the hash of something tied to the user's session when it first initiates the OAuth flow. So the state is what basically ties that token back to that user. The value is then passed back and forth between the client application and the OAuth service as a form of cross-site request forgery token for the client application. Therefore, if you notice that the authorization request does not send a state parameter, this is extremely interesting from an attacker's perspective. Potentially means they can initiate an OAuth flow themselves before tricking a user's browser into completing it, similar to a traditional cross-site request forgery attack. This can have severe consequences depending on how OAuth is being used. Consider a website that allows users to log in using a classic password-based mechanism or by linking their account to a social media profile using OAuth. In this case, the application fails to use the state parameter. An attacker could potentially hijack a victim's user account on the client application by binding it to their own social media account. Alright, let's have a look at this lab. This lab gives you the option to attach a social media profile to your account so you can log in via OAuth instead of using a normal username and password. Due to the insecure implementation of the OAuth flow, attacker can manipulate this functionality to obtain access to other users' accounts. To solve the lab, use a cross-site request forgery attack to attach your own social media profile to the admin user's account on the blog, then access the admin panel. Okay. Alright, let's try this one. Okay, escape OX. Yeah, you can see all labs from that URL. The problem is a lot of times the lab uses information or relies on information it's told you back. Like here, like this flawed cross-site request forgery protection leads into this lab. And if you just go from the all labs page, unfortunately you don't get that information very well. Okay. So let's log in using the username and password we've given. I'm just going to zoom in. Okay, so I presume attach a social profile. All right. All right, let's try logging in. Oops, hot dog, right? Oops. I'm actually going to intercept this request and just see if it's going to do anything weird. Okay, so it actually just logs in, that's fine. Continue. Okay. So let's have a look at the requests. There's got to be one that adds. This is going to be an interesting one. I'm not entirely sure what to cross-site request forge. Let's see. So this was the original thing. I'm guessing we can try and just, I mean, this is the thing that it needs to add, right? Unless... oh, actually, it might be this. OAuth linking code. Let me just copy that and see if that is anything in Hackverter. It might be... okay, probably not. So I'm guessing maybe if we try and do a cross-site request forgery here, copy the HTML. I'm going to go to the exploit server, paste that, store it, and deliver the exploit. Okay, and then if we log out, we can view the access log and see if it actually got hit. Alright, they did view it, I think. Which hopefully means if we log in... no. Honestly, I'm not entirely sure how to do this one because I'm not entirely sure what they want us to cross-site request forge. I guess we can look at the solution and see what it means. Okay. All right, that's why it didn't work. So it didn't work because this generates a code which we need to reuse, I guess. Okay, that makes more sense. But we'll intercept this request again. Hang on. And hang on. Okay, right. So if I click attach a social profile again, because I'm already signed in, it's just going to reattach it. So this makes sense. If I intercept the request, click it again, and then copy this URL, because this is just a GET request. Or in fact, if I just go to engagement tools, generate, and copy this HTML. Actually, that's not a GET request, is it? You know, I'm just gonna make it easier. I'm just gonna copy the URL and we're just gonna do a regular image tag. Okay, I'm gonna drop the request, turn the intercept off. That's gonna get dropped, that's perfect. If I go back to the exploit server, and then what we'll do is in this body, we'll just do an image tag and we'll paste this, store, deliver exploit to victim, and view the access log. So there's a delivery. I'm guessing. I'll have to read up on that. Al has read. Let's go back and see what happens when we log out and log back in again. Yeah. This is kind of annoying. So we did this. Create an iframe. Was it OAuth linking that we... Get OAuth linking. So we definitely did that. Did I change the code? Did it ask us to change the code? I don't think it did. It's asking us to drop the request. I guess what we'll do is we'll use their method iframe. Maybe that doesn't work. So we've linked social media. We did step 1. We noticed this. Turn on the proxy interception. Okay. And select attach social profile option again. So we'll do that. Okay. Forward any request until you've intercepted one for get OAuth linking code equals. Okay, so that's not the one. Forward that. Okay. I think I got. I must have, for some reason, got the wrong one then. All right, we'll drop that. So I'm guessing image tags actually do work. Store that. Oh, hang on. Turn that off. Deliver exploit to victim. Okay. When the browser loads the iframe, it will complete the overflow. Go back to the blog and select that. Okay, so what we'll do is we'll go to the access log and make sure they've gone to /exploit, which I think they did. Either way, log out, log in with social media. Yay, okay. All right, so it was literally, I was intercepting the wrong thing, I think. So I must have, when you do the OAuth link, I think I intercepted this request instead of the OAuth linking one. Okay, so we just need to go to admin panel, delete Carlos. That's generally the thing you do when you're an admin in these. What does deliver victim to mean? So yeah, if you look down here, deliver the exploit to the victim. Effectively, whenever you're in these labs and you have access to this exploit server, they call it. If I go back, you'll be able to store on this server any kind of file. So you can type the file name, you can set custom headers, you can set the body, and then depending on the actual lab, you'll have a different number of things here. So store basically means save everything. You can view the exploit, which will just load it in your browser. Deliver exploit to victim generally is for labs which require some kind of interaction with your victim. So in this case, cross-site request forgery requires the victim to load the page. So in this case, deliver exploit to victim just means that the quote-unquote victim in this case, which is the admin user, will be forced to load this page when you click it. So it's basically phishing, right? It's kind of sending them a link and they click it automatically. So it's just to show how the attack can work, obviously. But okay, that made much more sense. It's kind of more of a cross-site request forgery than an OAuth thing, though, I feel. But let's go to the next one. I think this one I've actually done before. I think I have a bug bounty for this. Perhaps the most infamous OAuth-based vulnerability is when the configuration of the OAuth service itself enables attackers to steal authorization codes or access tokens associated with other users' accounts. By stealing a valid code or token, the attacker may be able to access the victim's data. Ultimately, this can be completely compromise their account. The attacker could potentially log on as the victim user. Depending on the grant type, either a code or a token is sent via the victim's browser to the callback endpoint specified in the redirect URI. Remember, we saw that redirect URI parameter. If the OAuth service fails to validate this URI properly, an attacker can construct a cross-site request forgery-like attack. So you can trick a victim's browser into actually sending the code to an attacker-controlled redirect URI. Yeah, so this rings bells because I did get a bug bounty with Homebrewer on this. So effectively, I sent him a URL which he clicked when he was logged into this site that we were doing a bug bounty on. And the URL contained this redirect URI, which was pointed to my Burp Collaborator server, and I got his access token and then logged in as him. So that was fun. So I think if this one is good enough, I think we should be able to do this one. So a misconfiguration by the OAuth provider makes it possible for an attacker to steal authorization codes. To solve the lab, steal an authorization code associated with the admin user, then use it to access their account. Delete Carlos. Okay. So we will do this. All right, we'll log in with social media, Wiener and Peter. Okay, click continue. All right, there is an exploit server. So let's have a look at what happened. I'm going to close this one. All right, so was it this one? Yes, I think. Okay, so effectively this redirect URL automatically points back to the site that we were trying to log into, right? And it's used to redirect the user. But what we can do is put our own URL in this. So if we copy this URL and we go to our exploit server, what we want to do is, I guess, deliver exploit to victim. The admin user will open anything you send and always, okay. So I think we can do the same thing again. So we'll create an image. But instead, what we're going to do here is we're going to put in our exploit server URL. I'll take out the extra // and we'll end that, and we'll end the body. Let me open the access log. Okay, so if we deliver exploit to victim, here we go. All right, so we delivered it to the victim opened it here. You can see the IP address changed. And what happened was, so this was the auth process, right? We put in our own redirect URL. So they authenticated using OAuth, and then the OAuth server didn't check that the redirect URL was valid. And so instead of sending us instead of sending the admin user back to the original redirect URL, it used our bogus one. And so we got this call with this code, right? So we should be able to just go back to this account, substitute this. Oh, you've already logged into session. So if we log out and, oh no, maybe if we click that, log in. Internal server error. I guess actually, okay, I know what to do. What we'll do is we'll intercept the request and we'll just substitute the token. So we have a valid token here. So we will click intercept. Intercept actually, I'm going to log out first. Log out of that. Intercept on. Log in with social media. Okay, we don't care about this. There's the code that is our real code. Now if we substitute the admin's code, I think we get an install. Ah, lovely. Oh, hang on. You successfully logged in? Nope. Alright, I'm going to log out again. We're going to resend this and get another one. Let's refresh. There's our second code. Intercept on again. Let's log into social media. Don't care about this one. And we're gonna paste that. Okay, there we go. Okay, so I think it just wasn't as fresh. Okay, so does everyone understand what happened there? Hopefully everyone understood. But effectively we've exploited, actually now we've exploited all three components of OAuth, right? We exploited the actual client web app because they weren't checking that the access token was valid for that user. We've exploited the user themselves by doing cross-site request forgery attack. And this time we actually exploited the OAuth server because the OAuth server wasn't verifying that the redirect URL that we sent was actually valid for that client ID. And that's something you definitely should be doing. But like I said, I have done this one before. I don't think the write-up is unfortunately public, but it was a valid bug bounty. It was a free bug bounty. Unfortunately, it wasn't worth any money, but it was still kind of funny that I could effectively log in as homebrewer. All right. Let's close all of those. Flawed redirect URL validation. Oh, this might be. I wonder if it actually has a lab. Does it open redirect? If this is expert level, we're just going to ignore it. Okay, it's practitioner. I'm just going to read up on this. This might be slightly beyond the scope of what we're doing today, but we can always give it a shot. So it says, against more robust targets, you might not be able to submit an external domain as the redirect URL. But you can change the parameter to point to any other pages on a whitelisted domain. Try to find ways you can successfully access different domains or paths. For example, the default URI will often be an OAuth specific path, which is unlikely to have any interesting subdirectories. However, you may be able to use directory traversal tricks. Okay. Let's have a look at the lab. No promises we can even do anything with this one, but we'll have a go. Identify an open redirect on the blog website. Use this to steal an access token for the admin user's account. Use the access token to obtain the admin's API key. Okay. So what we're looking for is an open redirection. So let's scroll down the bottom. Sometimes they hide stuff. We'll view a post. I wonder if I do test at test.com and test.com. Oh. All right, let's see if any of that had a redirect in it. It's not looking like it. I'm guessing. Nope. What was that? Let's view the source code a little, I guess. Line wrap those. So that's just the header stuff. Okay. Ah, there we go. Next post. Did you see that? If you hover over the next post, you probably can't see it on the screen. So what I'll do is I'll go here. If you see this, we've got /post/next, and then a parenthesis. So the query parameter path equals /post, whatever the post ID is. So this is going to be an open redirect. Okay. Presumably. Okay. So what we should be able to do is if we put, let's just try http://example.com in there. I'm guessing, yeah, it's going to redirect to example.com. We have a lovely open redirect that we can use. All right, so let's go back to the lab documentation. So saying that with the callback, right, that redirect URI, maybe we can get something. So what we're going to do is we're going to go up here. I'm going to intercept the request. We're going to log in with social media. This URL, what we're going to try and do is put this in. So in this case, what we'll do is // and I'm guessing we actually need to use our exploit server, which I can't, but we can use that URL of the exploit server. So all right, let's see what that does. This might be completely a shot in the dark, but we'll see. All right, sign in. We have our credentials, Nina and Peter. And continue. Okay, that seemed to work. That redirected to our exploit server, which means if we view the access logs, Did we get anything? I'm guessing. So it should be in the referrer, right? The referrer header should have the information. This is a tricky one. I'm trying to think exactly what I need to do here. This is definitely how we do it. So we need some way of submitting this. So this did work. Oh, actually, hang on. Oh, I see, because it... Right, it puts it there. Actually, okay, so we can steal the access token from the... if we deliver it to the exploit server. Okay, this is okay. So if we grab it from the exploit server, what we need to do... is write some JavaScript that's going to take the 2 seconds. It's I think we can actually copy some. It's going to basically, here we go. Right, we can put this code, the same code that we use on the OAuth callback page. We can basically copy it. And we can potentially use this because we're getting the user to redirect here. We'll have the access token that we can grab, and then we should be able, hopefully, to figure stuff out. All right, so we want to fetch. We really just have a constant token, so actually we should just be able to fetch this with, let's just say token equals, and then plus token. Method get, we don't care about headers, that's fine. Okay. I don't think we even need to do any of this. Let's just try it. I have no idea what I'm doing right now, by the way. But effectively, we know that we can redirect the user to our exploit server, right? We also know that in the URL button, in the fragment, right, there's going to be that access token that we saw before. And so... since the fragment will be available here, right, we should be able to extract the access token from the fragment. And then all we're going to do is we're going to use fetch. We're just going to make an HTTP request and just append the token. I think this should work. I am not confident, but we're going to do it anyway. All right, so... let's see, I need to intercept requests again. Okay, so we're gonna log out, and then we're gonna intercept the request, log in with social media, and then the redirect URL, we're gonna do // it was post next path. Okay, so sorry, hang on. I'm going to copy this again just to make it a bit easier. Right, post next path, and then we need that URL. Okay, and then we'll forward that, turn the intercept off, And I don't know if that worked or not. Oh, actually, hang on. View exploit. Let me see what went on there. Hang on, we did... Okay, we did get the exploit. Oh, so no, hang on, we did do it. Look, it happened. So... Oh, I didn't change the URL here. Okay. This URL obviously should be here. Right, so I should switch the token out. Okay, this should have worked. Let's do it again. Luckily, I have this complete path now, so what I can do is... just give me a second. Where am I? I need to find the authorization. Right, here we go. So this redirect URL, the modified request should be correct still. It's ACD. Yep. Okay, so what I'm going to do is I'm going to copy this redirect URI that we already had. Okay, so let's try this one more time. Okay, are we logged in? All right. This is basically all. This is going to intercept my own request, by the way. It's not going to. We'll deal with the admin in a minute. Okay, so copy. We're going to replace that redirect URI with our fake one. Forward that. Okay, and then if we go to the access log. Why is that not working? Yeah, and the log should show us the stolen token. All I'm doing, I'm redirecting the user to this page on the exploit server, and then it's taking out the parameter out of the URL and making a GET request. But for whatever reason, I mean, even though it says it is. Oh, hang on, it didn't this time. Wait, what did I paste? Hang on, I'm gonna use this as a... That's why. Okay, I left out the exploit. Okay. This should work, he says, for the 7th time. This is like a lot of this is literally just trial and error. Especially if there's an answer. I could be looking at this answer here, right? But I'm not gonna. This seems like we're very close. So log in with social media. Paste this here. There's the /exploit. That's our exploit server. There's no space there, right? No, that's good. Okay, forward and turn the intercept off. Okay, this looks good. That looks good. All right. Let's refresh the log. There we go. Okay, so we got our own token. Now we need to figure out how to get the admin's token, which I'm guessing, honestly, we can just do by... Like the fetch happens in the background. So what we can do is maybe put a timer, and after this is done, redirect the user. So let me see, JavaScript redirect. Oh, hang on. What do I want to Google? I guess redirect after 5 seconds. There we go. Yeah, that'll work. All right. Let's just try this code. Okay, so we want to redirect the user. Oops. Yeah, we want to redirect the user to. Where do we want to redirect them? Oh, they always have a active session. Okay, so we want to redirect them to the auth page, I think. So we basically. Right, we want to redirect them here. Okay, so copy this URL and paste it here. Alright, I think this is going to work. So let's firstly view the exploit. I'm just going to close a bunch of these down. So after 5 seconds, it should redirect us. Perfect. Okay, yeah, I think that worked. Let's deliver the exploit to the victim. View the access log. Ah. Okay, so this was us. Oh wait, no, that makes sense. There we go. Okay, we got tokens. So the token null was when they visited the page originally. That's why. So I think this is the token. Oh, it's auto refreshing. So I should probably actually. You know what? We'll just try it. Log on to social media. Forward. 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 Token. Do we know their admin account? Administrator. Okay. But the API key is simply hidden. All right. So there's something else we're missing. Why do the 5 second sleep? So let's go back to the exploit server. I basically wanted to make sure it did this, right? But I also wanted them to visit. So what I didn't want them to do is basically we're only delivering one page to the victim, right? In this case, the admin. And so in this case, I need to redirect them to our actual exploit, which contains the callback. But at the same time, if they've come from this URL, which they get redirected back here, we need to also send this GET request. So there's kind of two things happening on the same page, depending on where they've come from. And so I basically want to make sure this always fires. But at the same time, if they've only come here the first time and they don't have this token in the URL, then this should fire. This is a very dirty way of doing it. I could have just checked whether the token existed. And if it didn't, then fire this. This is just a very quick way of doing it. I mean, I'm guessing technically we've done it, right? They ask you to grab the API key, so I'm guessing we have to try and enumerate some other functionality here. Because I'm not entirely sure where the API key is. Use the access token to obtain the API, the admin's API key. but we are logged in as admin. I'm counting this as a win. Cannot access the admin's API keys. Yeah. Duh. I wonder if there was anything else in the access log that we missed. The admin is basically constantly logging in, by the way, because they're in a redirect loop, which is kind of funny. I don't know. Maybe it's... I'm honestly not sure about how to actually solve this. Is hidden a URL? No, I think it's just... Yeah, it's just text. It's kind of annoying. Because I feel like this was this was the biggest challenge. Okay. I mean, I'm probably not gonna. I won't look at the answer, but unless people want me to. But I feel like this was definitely, you know, we actually did log in as admin, so we showed that it could be done, and we showed why. So I think that's probably okay. And also I am coming to the end of the time I did allocate for streaming, so I wonder if is there another sealing OS access tokens via a proxy page. Okay, that's expert. We're not even going to attempt expert at this point. You know what? Maybe a call to an API endpoint. Yeah, there might be one. But I have to enumerate endpoints, you know. I guess what we can do is we can just try some random ones. Problem is, it's like, it's not... There's like nothing here that suggests what it could be. I think what I'm gonna do is I'm gonna like take a peek and okay. Is it the get me? Is it literally just no? There was a get me. I did notice that actually. Oh, okay, right. And so I think so. It was there all along. What we need to do is use the access token as a bearer token, I think. So let's just copy the latest one. It's not the latest one, but okay. So bearer. No, hang on. I'm gonna resend the one I saw here. Repeater. Okay, there we go. That was all. I should have probably looked at the freaking /me thing. All right, but at least we can submit that. Hooray, solved. Yeah, it's okay. We cheated a little bit, like, but I guess if I paid more attention to this thing that was popping up every now and then, maybe I would have noticed that's where the API key was. But okay, we just followed Enik Kaduk. Oh, sorry, Enin Kaduk. I apologize. We also got Death Camp 4QT a few minutes ago. That was nice. All right. I think that's a nice place to end it, honestly. I was only going to stream for an hour, and it's been like an hour and 15. I do intend to stream multiple times this week. I'm trying to get to affiliate level on Twitter, which I think I need to stream on like 7 different days. So I think this is the 3rd. So I'm hoping by the end of the week I'll actually have affiliate status. And in Kaduk, if you're late, you can watch the VOD. It should be available after the stream ends, so you'll just be able to go to my Twitch and rewatch it. So yeah. It's a good stream, I think. Hopefully, we did blunder about a bit, as I did admit at the start. OAuth is not something I'm particularly strong with, only because I haven't found it enough. But I think we got there. We did quite a few of the labs, and so that was kind of nice. Did I miss anything in chat while I was literally writing random JavaScript? I am gonna scroll up and see. Portswigger Web Academy. So Kachalimbu. It's not a new site actually. It's a couple of years old, I think, but it's free, so you should definitely check it out. You can create an account for free. You can use all of the labs for free. Cool. Yeah, I think I didn't miss anything else. Perfect. All right. Yeah. Well, thank you very much, guys, for watching. Have a great rest of the day, and I will see you next time.